Hey everyone, welcome back to the channel. Today we are diving into fascinating lead code problem which is kth symbol in the grammar. This problem is not only intriguing but also great as exercise in understanding. Okay, let's see the problem statement what is trying to say. Okay, we build a table of n rows which is one based indexed. We start by writing 0 in the first row. Now in every subsequent row, we'll look at the previous row and replace each occurrence of 0 with 0 1 and each occurrence of 1 with 1 0. Okay. Let's go to the iPad screen and let's understand what exactly he meant. Okay. See, they said that they have a table which is one based indexing. So first row which is 0 and second row 0 is 0 1 it became. Third row 0 again became 0 1 1 is given that it should be 1 0. For fourth row 0 1 1 0 1 0 and 0 1. Okay, so these are the binary sequences, right? So binary sequences, it continues to generate, like how many rows, n number of rows, so that many binary sequences will generate. It continues to generate it. But here we need to find kth symbol in the grammar. Kth symbol in the grammar, in a sense, we have to find a position or a particular kth symbol is either 0 or else 1. That is what the problem is about. So, but it is interesting where here it is a table and which is row wise. How to find out a symbol in that such sequences? Is there a way? I mean, see, each row has different lengths. Year 1, year 2, year 4 and year 8. Okay? And likewise, how to find out the kth symbol in such sequences? How to find out the length? We can find out the length of each row by 2 to the power of n minus 1. Okay, let's do. If I want to know fourth row length, 2 to the power of 4 minus 1, which is 2 cube, which is nothing but 8. What about I want to know the length of third row? It's nothing but 4. So the length of each row is determined now. Now I want to explain a pattern here. What pattern I am talking about? See, in the first row it is just a 0. In second row it is 0 and 1. From third row there is a beautiful pattern. You can observe that the first 2 is similar to the previous and next 2 are the complement of previous, right? It's nothing but this whole thing is divided into a sequence is divided into two parts, which is 0 1 and 1 0. It same goes to second sequence as well. See, if you observe first row it is just a 0 and the other half it is complement of first row, right? You can see this whole thing is nothing but left and this whole thing is nothing but right. The left sequences are nothing but the same sequence of previous, and the right sequences are nothing but complement of previous sequence. So that is the pattern here I can observe. Why I'm using a pattern here? See, if I want to know 2 to the power of 5 minus 1, which is 2 to the power of, okay, n is 4, k equal to 5. Okay, if I want to know n equal to 4 and grammar is I want to find out the symbol of a grammar which is of fifth. So the fourth row I want to know the fifth position, what is the grammar. Okay, but we can say we can find out from the complement of previous, right? So complement of previous is nothing but this n equal to 4 equal to 5 just turned into previous is nothing but 3, and the complement which I will remove the mid because the mid is here 4, right? K minus 4, that is 5 minus 4 equal to 1. Oh, okay. So how to find out mid here? Is there any such formula where we can find out the mid in the sequences, in the binary sequences, and it is continuously in such rows we have to find out the mid for each row? How can we do that? From same length of each row of binary sequence, you can say the mid is 2 to the power of n minus 2. Consider if I want to know fourth row mid, it is nothing but fourth row, which is 2 square is equal to 4. As the length of the sequence is 8 and that mid is 4. You got it? So we got the mid. And if I want to know, see, kth grammar, I want to know fourth row fifth symbol. Okay, what is there in that? This goes to, it goes to inner, it does inner curves. Okay, it does inner curves. Kth grammar and whatever present in 3, 1. It again do inner curves becomes, it again does inner curves kth grammar 1, 1. When it reaches 1, it returns 0. Why? Because when n equal to 1, first row, it should return 0, right? So first row, and here also the first place is 0. Okay, but the complement of it is nothing but 1, right? So that is a dry run. And the time complexity here, it is O of n, and space complexity here O of n. Why? Because it takes the extra stack space, right? Let's go to the lead code and try to code it. Okay, see, as I mentioned, we have to take first row as a 0, we have to return 0. Okay, then I want to find out the mid, equal to math dot POW. I'm using the formula to find out that. Okay, then I will check if it is a k kth symbol of grammar is present less than mid or else greater than mid. If it is less than mid, what will I do? I will just return the previous row. Okay, if kth symbol k is less than or equal to mid, then I'll return kth grammar n minus 1 comma k. Okay, else I'll return complement of previous row, as well as we have to change the position. I mean, if it is a fifth, then it returns 1, right, one place. So I'm doing the same thing, n comma k minus mid. Okay, let's return. Okay, it is successful. Let's submit it. It is 100%. So can we furtherly optimize this? We can't exactly optimize. There is a one line answer to it. I will explain that how. There is in Java, there is a function called as integer.bitCount that usually counts the signed value of bit. So how exactly we are useful? Let's see. Let's go to the iPad screen. I'll tell you. Okay. First row length is nothing but 1, and second row length is 2, and third row is 4, and fourth row is 8. It's nothing but 2 to the power of 0, 2 to the power of 1, and 2 square, and 2 to the power of 3. Right? It is similar to the bit manipulation or binary number of particular place, right? What if I say from kth grammar itself take n equal to 4 and 5. So I want to know integer dot the count of signed values. The signed values integer dot bit count of k minus 1, which is nothing but 5 minus 1. So what is the value of binary number of 4, which is nothing but 100. So how many ones are there here, or signed values, which is 1, right? So if it is the count percentile 2 equal to 0, then return 0, else return 1, because for even places it might be 0, right? For odd places it might be 1. So based upon that, I'm just returning it. So yeah, that's it. Let's go to LeetCode and try to do it again. Okay, int count equal to integer dot bit count of k minus 1, right? And return count percentile 2 equal to 0, then return 0, else 1. Run it. Yeah, it is successful again. So yeah, that's it. We have successfully tackled the kth symbol in the grammar. If you enjoyed this video, don't forget to like, subscribe and hit that notification bell. Yes, or if you have any suggestions to any certain problem, please try to comment. See you again, guys. Thank you.